We continue on CUDA programming. Well, I am just starting. I gave some introduction in the last class. So, CUDA full form is Compute Unified Device Architecture. So, why this word? Unified is unification of CPU and GPU. Okay. So, here we are running our program on both the platforms, CPU and GPU. Okay. It will become clear with the example, but I did told you that CPU is a director and it does simple works, and for complex works it just offloads to GPU. That is a basic idea. So, we need to continue on C a bit, because basically CUDA is in C. So, the one I am showing you. So, we just had to learn new tricks, how to offload work to GPU and threading. Okay. So, threading is this parallel programming in GPU is fundamentally different ball game. Okay. You will see when I am going to show you the examples. It is not like multi-threading in OpenMP or OpenMP, it is different. It is threading, but the logic is different. Okay. So, we want to send basically we will use lot of arrays. It is for number crunching and we will have arrays. So, I want to pass arrays as a function arguments. In C, this is this is a recap. Okay. If you know C very well, this is just a recap. If you do not know, then you should just pay a bit more attention. This A, B, C are 3 arrays. Okay. These are 3 arrays, and either you can in CUDA programs we prefer this star A, star B, star C, these are pointers. Okay. So, A, B, C are address of the array. Okay. So, we send the address of these arrays to this function add. These are parameters, and this function will do the addition of A, B is element by element addition. A I plus B I is C I for a loop, n is the number of elements. So, you should use star pointer because address that is what is preferred thing in CUDA. This is of course allowed as well, A bracket, B bracket, C bracket. So, this thing also works in a normal GCC, but CUDA people normally use star, okay, pointers. And I hope you understand, pointer is basically not basically, pointer is address. So, this array will reside either in GPU memory or in a CPU memory. Okay. So, CPU knows the address of the GPU memory. Okay. So, this address is what is being passed, and that is why it is very clear that A is address. So, the director will say, well, do this starting from that address in GPU, and the main program is here A, B, C, these are arrays of size n. I am not giving you the full program. N is normally for your course you can say define n 10 or 1000 or 10,000 whatever, and I initialize. So, I am right now this is a C program. Okay. This is simple C. I am not thinking of GPU right now. So, this is initialization and add. So, the basic point I am trying to say is in C arrays are passed as argument as pointers. That is a strategy, that is a C design. You do not pass the array as array elements are not passed, array pointers are passed, and so there is one advantage of this. Why do I pass pointer? Why do not I pass the array itself? You may know this thing, this call by value and call by reference, these two words, yes or no? Everybody who knows programming should know this. Call by value, I send the full data is a argument. So, that thing is copied. Typically, when I pass an integer, that integer is copied there. I mean, when I say if I pass integer int c or int x is a function argument, then here x will be. So, I call f of a, then a will be copied into x. So, there is a copy made, and then whatever I do with x, a is not affected. Okay, this is called call by value, a remains unchanged. Python is a bit tricky. Python I will not tell you right now, but Python is tricky. Python is not value, Python is object stuff, but let us focus on C right now. So, a is copied there, and I can say x equal to x squared, x becomes a squared, I can print x and so on, but nothing happens to the original a. So, this call by value. When I call by reference, then I basically send the address. You put an upperset here, call by when you put a reference, then once you put basically you get the address. Once you get the address, then the function will modify the object. Okay. So, arrays are passed as a reference. I am passing the address. So, I want the array to be manipulated. When you say C is added here, no, Ci is ai plus bi, C is altered by the function. Earlier C may be zeros, but now C is sum of ai and bi, Ci is sum of ai and bi. If I pass by value, then it won't change it, right? It will remain, the original C will remain as is. Another major problem if I pass by value this arrays will be that huge data size. My arrays are typically billion numbers or million numbers, and I do not want to copy those arrays. So, essentially pass the address, and there is only one copy of the one array in the memory, and that array is being used for all the operation. So, it is always a pointer which is passed. Now, 2D array is a bit more complicated. This is because of C. Okay. Now, I am not very fond of C, but in CUDA you need to use C, because you need to, I mean, as soon as I go to pointer, I look at this star star, then I have to think about that. It is not very natural to look at a C syntax and understand it. It is not very obvious when you look at it, complex C programs. In any case, this is well, we need to CUDA, we need to pay attention and use C. So, A3 2. So, two dimensional arrays are, well, this is one way to do it, there is another way to do it which is more complicated, I will not do it in the class. So, it is a matrix, 3 rows 2 columns, but imagine this pretty complex syntax. In Python it is 3 comma 2, right, but this is C is, well, there logic behind it, but you see this is different. Now, this is similar to Python. Okay. So, it is 3 rows and 2 columns, it is 0 1 2 3 4 5 row measure. Okay. Now, this is a 2 dimensional array. So, my so I can also need to know what the A means. So, A is a pointer to the first object, first number. What is first number? I put it here, 0 is the first number. So, these are stored in a memory, they are stored as 6 numbers, in fact, they are consecutive. If I look at memory, it is going to be 0, 1, 2, 3, 4, 5 in sequence. So, there is the address, and that address is A. Is that clear? It is like 1D, like 1D, but not 1D. But what is star A? You may think that star A should give me the value of the first element, right. For 1D array, star A gives me the value, right. I would be expecting to get 0 for star A, correct, but no, it is a 2D array. So, what is star A? Star A is the address of the first column, first row, first element of the first row. If I want to get the first number 0, then I have to put star star A. So, this so star A is the address of this star A and A are the same for here right now, okay. But star A is the address of the first element of the first row. So, this star A is the address, and I put another star, then I will get the value. So, star star A is 0. Okay. So, two dimensional array there are two redirection. This operator is called redirection operator, or you can say that it gives me the value of the memory, okay, of the variable. Well, give me the address, put star, then I will get the value at that address. Is that clear? Star plus, well, now star plus 2, what will star plus 2 do? Star A plus 2. Star A is the address of the first element of the first row. If I add 2, then I will be skipping 2 elements and I will be reaching here, right. So, star plus 2 is the address of the first element of the second row. It is not giving me the value 2. If I put another star A plus 2, then I will get 2. Okay. So, this is a 2D array. So, this is the complication. Okay. So, I hope this is clear. I need to put 2 stars to get a value, 2 redirection. So, 2D array is like a 1D array stretched, that is why I put 2 here. I mean 2 is, and when I put star A plus 4, I add this address plus 4 more. There are more complex data structures where each row can be of different number of columns. Like in a list, no, I mean you can have I could have element like this is A, B, then I have C, F, G, and this is the full list. So, there are, it is not homogeneous, no, it is not, I can't say it is 2 by 3 or 2 by 2. So, this is allowed in C. So, now I can access any element very conveniently. I need to get this row first. So, row will be star plus A or star A plus 1, then put another star. So, this is the second row, then, so this is the first element of the second row. I want another let us say fourth element. So, if I put a 2 here, that will give me G 0 1 2. Okay. Anyway, I do not know whether you need it or not, but this is how we need do 2D arrays, and it just shows you that you need to be comfortable with this pointers. Yeah.
What is the difference between A, star A and ampersand A?
Ampersand A is allowed for arrays. It gives me the address only, it does not give me anything else, but ampersand is it gives you the inverse of star for any object. Just think of ordinary variable x equal to 5. So, x is a variable name, it is stored somewhere, right, 5 is stored somewhere. How do I get that location? Ampersand x. So, ampersand gives me the address given a variable, and so this is a pointer is the address, but I want what is stored in that pointer, then I put a star pointer, that is 5. So, ampersand and star are opposite operators. In fact, that is just keep that in mind, you will go quite far.
So, actually if you know the address, then how can we access the value from that?
Star pointer, that will give me star is the, it will tell you what is there inside. Star is directing you to that place. This is only one level of redirection. Okay. But for this object, I need 2 levels of redirection. First, I need to know, for example, in New York there are streets. Now, house in the street. So, how do you go there? First, you give me the street, then location of the house in that street. So, first redirection will be the street, then house. So, you need 2 stars. Okay. So, these are for because operating system design, location you need to get, you need to create arrays, all that. Okay, that is why all this stuff are done. Yes.
In 2D arrays like star and ampersand are same.
Yes, that gives me the same thing. When I checked, it does give me the same thing. Yes, this is a more complex example. It is not same as what I have it here. Either a 2D integer array like this, a 2D matrix. This is basically a matrix. In physics, we normally use this matrix, right? For matrix, this is what we do. Had it been list or object of strings and so on, which is allowed, then how do I navigate? So, this structure of pointers and address are very general. So, every street of New York or Kanpur need not have the same number of house. Then how do I get to the house? So, first get the street. So, I say, so my house data structure may be H. So, H, so then and street is S. So, first I need to get star H. So, this will give me the first street. Okay. So, this is the first street or 0th street. Then if I want going to third street, then 0, 1, 2, 3. So, put 3 here. This is the street address. I want to go to the 0, 1, 2 house number 5, 0, 1, 2, 3, 5. Then put another star plus 5. So, that is how I do it. Okay. But we ignore that. Okay. I mean, if you want to master C, then you need to go there, but we do not want to get so far. Okay. Okay. Some of you will need 2D. If you are doing this finite difference, then 2D will be required. No, I mean for XY model, 2D will be required. So, just be careful when you use 2D. Often 2D is stretched into 1D. In fact, that is what is being done. I am going to show you some example right now. A 2D will be stretched to 1D, and that we work with 1D. And the logic is not very difficult. You just have to keep in mind that I am working with 1D. Okay, so we are just looking at some operators. So, this is the same array. Okay. So, let us look at some numbers. So, a pointer is this is a pointer which is address of A00. So, which is A00? This one, right, which is number 0. Address of that is a pointer which is basically A. Okay. So, I am going to print all of them. A will be same, star A will be what? Star A for 2D array is a pointer, it is not a number. So, star A is same as, so these 3 will be same number, star A plus 1 will be address of this which is shifted. Okay. This is because of its 2D array. Okay. So, let us look at it the stuff. So, these are 3 numbers are the address which correspond to this same. It is hard to read, but they are same. Next is the 4th number which is star A plus 1, which is offset by 4. So, I need 4 bytes. So, that is the 4th byte this address. Okay. Please keep in mind that I am not this is word size, no? This one is not, I am do not add 4, this is next number. I am not saying not, I am not looking at next byte when I write a program, next number, but my byte, this is the address of the bytes. So, the difference between this and this is, you can see that everything is same except 0 is replaced by 4, which is 4 bytes for integer. Now, if you look at the other next line, star A plus 1 star. So, star A plus 1 is what? This address star A plus 1 is an address. I want the content of that address, then I put another star which is 1. So, this is what I get 1. Then star A plus 2. So, I go to star A plus 2 which is address of this, then I put another star, I get 2, then plus 3 which is this 3. So, we can access any number by putting 2 stars. Please keep in mind that this format is percentage %d for integers, percentage %p for pointers, this percentage %p for pointers and percentage f for float. Functions for with 2D arrays, how do I pass that as a parameter? No, we will need to pass parameter, and you need it for CUDA, because CUDA will do the function, do the execution. So, a function has to be written which is which will be executed by GPU. So, these are all right now CPU functions, but we will convert it to GPU soon. So, it is a 2D thing. So, I given row column as a argument for this function 2, and matrix I give the rows and columns in that. Okay. This is one way to do it. I am not putting star here, but I will show you another example where I put a star next in the next click, and I do the loop. This is straightforward, anybody can write that, and it is printing the entry of the matrix. Okay. This is straightforward. This is how I would write a code without worrying about stars. Stars does confuse me, and I think it confuses almost 50% of the people, well probably 90%. Okay. So, this is how we write C code, but with CUDA we need to go to star. So, the function which is with pointer is, there is a one level of pointer matrix. I am not putting double star. No? So, double star is also possible, but I am not writing that example. In Colab, which I will share with you, which has 2 stars. Okay. You play around with it. It is clumsy. I was getting a lot of errors. So, this is when I call it this function. So, first function is easy to call. This is function 2 call. I declare this integer array A and I call. So, this is row, column and A. A is my matrix. The second one is a pointer with 1 star. No. So, if I put one more star, I should get the value. So, if I put 2 star, then it will be just A, but I have already this is pointer with only 1 star. So, I am giving A0. So, it is the first row index. Okay. Otherwise, if I do not put 0, then it does not compile. There is a logic behind what is C is doing, very logical, but it is frustrating often. I mean, okay, it should work, but it is not working. And once I have the pointer, then I can loop it, but I am using the pointer only here. So, once I need to get the address of every element. So, this is the first, remember I had this 3 rows 2 columns. So, I am here. Okay. So, I can get anywhere by matrix first address plus I star column plus j. Okay. I is a row index and j is a column index. Is it clear or not clear?
It's kind of 1D.
Is 1D. So, I have written this treats as 1D. So, most of this CUDA things is in fact is better to do treat as 1D. The stored as 1D is more efficient if we treat as 1D. You have to just do little bit of bookkeeping, which can be slightly disorienting for the mind, but is fast if you treat as 1D. So, it is 1D, you just keep going down in this like this, and you get the address. Okay. Or you can also use star matrix plus plus. So, it goes to the next one. Okay. So, this is how you can call 2D stuff, but you probably should go like this function for CUDA. So, another function you need is malloc. Okay. So, malloc is short form for memory allocation, M for memory and allocation is alloc. Why do I use malloc in C? Fortran, the usual Fortran, the normal Fortran does not have this kind of stuff, malloc. So, in fact, lot of functions we wrote so far, even in Python thing, we created arrays a comma 5, okay, or a I put 5 like this, right, float a5, right. No, so rather you write a np dot array, you give the number of elements, but I want the number of elements to be dynamic. Why do I need dynamic? Somebody else may need 6 elements. So, when I write a code or in Apple is writing a program, it should run everywhere with any number of elements, right. So, fixing this element is not a good idea. My array size should not be fixed. It should, the user should give me the number, give the number to the program, and program should run. So, in fact, it is a bad idea to put hard code the array size, and that is what is done in typical, well, I mean for short programs we just do it, but for professional codes we need to keep this n variable. So, you compile only once and then the code should run for any n. What if you change n here? I mean for C code, if I change this n A5, I make it A6, or normally, well, slightly better thing to do, but not the best thing to do is define /define n5, put in top and use n. Okay. So, this is called compiler directive. So, all n's are replaced by 5, compiler will do the work. Okay. So, when somebody says, well, I do not need 5, but I need 10, n to be 10, so then you change only one line, you just make it 10, but still you need to recompile the code, right. So, that is what we will do for professional code, MATLAB or anything for your flow solver. Once the code is compiled, you do not recompile, you do not reinstall a code. Okay. So, this is called dynamic allocation. My number of elements can be specified on the go, and that is why we need memory allocation. Give me the number of data points and I will create arrays of that size. This code does it. You need to worry about only one line. So, this is a malloc function, m is small, the m is small function, and C, by the way, you have to be careful, it is case sensitive. So, you can't use capital for small, not allowed. And how many data points? What is the size of the array? So, n star also gives the data size. So, it is creating bytes. So, size of int. So, size of int is 4. So, the argument for malloc is 4n. He is creating data. What you store is, in fact, your headache later. He is not going to check. By the way, that is another thing in C. If you make some problem, well, it is allocated for integer, and by mistake you put a float number. What does it do? You run C codes, know what happens? If you put a wrong type of variable, what do you get? Very frustrating thing comes, segmentation fault, right. You heard of this word, no? Segmentation fault. It does not give any error, it says segmentation fault. It is typically your memory, you are not doing it properly. Okay. So, it is a programmer's headache to put the right type of variable in this array, and it returns integer, and that will be the pointer, is address of the first location. So, I want to create, I want to store 10 integers. So, it is going to create this memory block of 40 bytes, and this pointer will be the first address. Well, this is not 40, but okay, you can 1, 2, 3, 4, 5, 6. So, it will store 6 integer 24 bytes, okay. And this part is I am initializing those that array. So, pointer I, by the way, pointer is name of the, well, you can choose array name, but right now pointer is address, which is same as name of the array. So, pointer I is perfect, no problem, it is, well, it is not perfect maybe, but it will do the job. Pointer I is I plus 1. So, it is storing numbers from 1 to n in this location. So, it is going to be 1, 2, 3, 4, 5, 6, okay. And I can read this n from the terminal, or I can pass that as a parameter from parameter files. So, in your code, in a project, you should make a parameter file. So, your code should read from the parameter file, okay. And So, you will have more than one parameter. You do not want to scan is not a good idea, because I am not going to be sitting there in a mainframe giving a number. Typically, your job will be queued in a supercomputer. So, queue means when your turn comes, the program will get inside, okay, and that time you are not going to wait overnight. Okay, my turn is coming. So, basically you will be putting a parameter file, and you ask the main program to read from the parameter file. Okay.